And then we stop after this. Which one? I'm going to choose 25. I don't know if that's what you wanted.
Can we do 24?
Let's do 24. So 24, we have limit as t approaches infinity, t plus 3 divided by 2t squared minus 1 with the square root. Awesome. Now, we know from some time ago that the square root of x squared equals the absolute value of x, not x, the absolute value of x, which we know, we refreshed our memory on this last time. It's x for positive and negative x for negative. This should be carved in stone in your memory now. Okay. Good. So let's see what situation we have here. In this particular case, we don't have to simplify. We can simplify. We can't. This is not a case in which I have to see the degree. Everything is there for us. Can anyone tell us where the numerator is going?
Infinity.
Good. Can anyone tell us where the denominator is going? I covered this because it's too small to mention.
Infinity.
Good. So this is that infinity over infinity indeterminate case, which, again, by indeterminate, we mean we have no clue. This can be anything. This can be anything. Look, would you have ever thought of infinity over infinity to be 2? No. So that's why they're called indeterminate cases. Anything can happen. You cannot draw any conclusion till the end. Good. So in this particular case, we continue exactly as we did before. What is the degree of the numerator?
1.
Yes, so we factor out t. Can anyone tell us what we have in parentheses?
1 plus 3 over t.
So we have 1 plus 3 over t. Awesome, brilliant. Thank you. Can anyone tell us what is the degree in the under the square root?
2.
Good. So we factor out t squared. So what is left when I factor out t squared from these two terms? What do I have left here?
2 minus 1 over t squared.
Brilliant. Awesome. Very good. Don't touch the numerator, but we have to do something here. And we have the square root of a product. I have the square root of a times b. Let me refresh your memory. The square root of a times b is the square root of a times the square root of b, assuming everything is real. This is real, and so on and so forth. But this is the property. But when I take the square root from t squared, I have two options. And you can say not so fast. You cannot have two options. When t approaches infinity, how can you have two options? You only have one. Which one?
Positive t.
Exactly. But what if I have here, don't change anything. What if I have here negative infinity? What will I write for the square root of t squared?
Negative t.
Exactly. Thank you so much. Who was that? Rick? Okay. So I have to write a few steps. I have to write the limit as t approaches infinity from t 1 plus 3 over t. I have to emphasize this property first so everyone knows what we are doing. Then I'm emphasizing or quoting, if you want, what you just told me, that the square root of t squared will be replaced by t only because t approaches infinity. And yes, of course, that's what I was hoping for. So where is this going? And where is this going? Again, because of this.
To 0.
And can anyone give us
1 over square root of 2.
that's it. 1 over the square root of 2. And which, because the approach is infinity, what does y equals 1 over the square root of 2 represent? At infinity only. We use the sign. Here we did not. Here we did not use the sign of negative infinity anywhere. So it's a horizontal asymptote everywhere because this is a pure rational function. But this, I used the sign because otherwise it would have been, this would have been negative t. Because I use the sign, it has to be at infinity only.